Hey guys, so this is going to be the Unit 4 test review, and Unit 4 is all of the atomic theory and, atomic structure and subatomic particles kind of stuff that we talked about. So we are going to take a test next week, and that would be the week of the 11th. So that's like probably Tuesday, May 12th or Wednesday, May 13th. I haven't decided which day yet. For you guys to take your Unit 4 test. And the reason I want to give you this test is because obviously we're cutting the school year short. So last week for seniors is next week. So I wanted the seniors to get one last chance to kind of show what they have learned over the past like month and a half that we've been doing this, and get one last kind of big grade in the grade book before we end the school year. So that I can look and see that you've, given effort and given you, and I can give you then your third quarter grade, or if you've exceeded, just giving effort, you can go on to get a better grade than your third quarter grade. So this review, I'm just going to talk about all the topics we kind of went over with all of our assignments and notes this unit, so that you guys can have a refresher over everything. For this video, same kind of protocol with the last test review video, which I know was like a month ago. No, it was over a month ago. So I know it was over a month ago. It was, probably long and forgotten. But with the last test, remember, I had you guys follow along with the review video, take notes on it, on the PowerPoint I use and the things I say on top of it, and then turn in the picture of your completed review notes. The reason I just kind of clarified is because I want you guys to write this. This is the difference between doing the video. I gotta keep hitting this thing. Doing the video review and doing a like a normal assignment. Because with the normal assignments, I let you guys have freedom in determining if you wanted to use Kami to edit a PDF and turn that in, type on a Word document, or do it the old-fashioned way with writing on a piece of notebook paper and turning a picture of that in. So I kind of gave you guys freedom, but with this, since it's a final review before a test, I told you guys my belief that writing down things really helps you kind of remember them and digest them into your mind. So I want you guys to handwrite this on a piece of notebook paper and turn them in. Just so you know, that snorting sound is not me, it's my dog. She snorts, so sorry. Anyways, so I want you guys to handwrite your notes from this video and then send me a picture of your handwritten notes on Google Classroom. The picture of the test review, of this test review notes, will probably be called on Google Classroom, it'll probably be called Unit 4 Atomic Theory and Structure Review Notes. So pretty straightforward. So that's probably what it'll be called. So look for something like that in Google Classroom, where you will turn the picture of this video notes in, okay? So before I get started and talking about the content, I'm just going to tell you about the structure really quick. So the structure of this test is going to be kind of similar to the last test, where you'll have a written and a multiple choice portion. So the multiple choice portion, I'll kind of go over questions I could ask you, but it'll gotta be in a Google form kind of structure, so that you will fill out the Google form first, and then you'll do the written portion, and then submit the written portion to me on Google Classroom. So just make sure you do both of those. Make sure you do both of those parts of the test, because I had a lot of people like with the last test, like only do like the written or only do like the multiple choice, and then they only got like half the grade that they could have because they only did half. I don't know how many points is going to be worth this time, so I'll let you guys know, and it will say on the test. But so that's pretty much the structure. It's going to be exactly the same, so you'll have a written and a multiple choice that you'll have to do. Okay, so now I will get started into kind of talking about the content and the kind of questions I could ask you. Okay, so I'm going to start talking about the actual review. So this is where you should start taking notes. So the unit was called like Atomic Structure and Theory, or atomic theory and structure, whatever. But so this is unit 4, and this is everything from the first thing that we did, which was like the atomic theory foldable thing with all the scientists, to what we did most recently, which is like the isotopes review, element math game, all that. So it's going to cover all of that, which may seem like a lot, but when I compiled it, they all just go over the same kind of topics over and over again. So there's only a few like different topics within this chapter, within this unit. But I give you guys kind of a lot of assignments so that you guys can really get repetitive with it and, you know, go over and over again it again so you can learn it, especially in this like tough time. Okay. So the first thing we talked about was the evolution of atomic theory, because I gave you guys the foldable, which that's why these should look very familiar, because the foldable, this is actually the answer to the foldable, it's the key. And then I did a video where I talked about all of the scientists and what they discovered and how they discovered it. So I'm just going to briefly go over them again. So first we had Democritus, right? And remember, he was a Greek philosopher. He wasn't really a scientist. Greek philosophers just kind of think things, and they're like, this is what I think. I have no evidence to back this up, but this is just, you know, what I think. And here's why. So, you know, he just kind of thought, where is my mouse? He just kind of thought that matter was made up of very small, little, indivisible particles called atoms, and that was short for atomos. And atomos just meant uncuttable, so he thought that all matter was made up of these little things that couldn't be broken down any further, which now we realize in 2020 that that's wrong. But back then, that's just what he thought. So he also, his idea of the atomic model was just, you know, a circle. He didn't really have any more information. He was like, they're probably just little circular kind of things that you can't break up. So that's why his is just like this circle diagram. Then we get to Dalton, thousands of years later, who took Democritus's idea and kind of did actual experiments with it. So unlike Democritus, who didn't do any experiments, Dalton, he actually did some. And so he came up with these 4 rules, these 4 postulates, he calls them. And they are, the first one is atoms are very tiny indivisible particles. So same kind of idea as Democritus, where he didn't think that you could break them down, which, like I said, we know isn't true now. But that's just what he thought. 2 atoms of one element are all the same. That actually is true. Well, for the most part. The third one was atoms of different elements are different, which we know is true. And then finally, compounds are formed by combining atoms, and that we know is true. So those are his 4 postulates. He didn't really say anything else about the structure of atoms themselves. So his model is still more of this circular bubble kind of looking thing. And remember, both Dalton and Democritus thought that you could not break the atom down any further, which, like I said, is not true. Then, like, I don't know, 90 years later, 100 years later, we have J.J. Thomson, who is this middle guy with the glasses. He did experiments and found that there is part of the atom is positive, and some is negative. Okay, so he found out that you can break atoms down, and within atoms themselves, you have positive parts and negative parts. And he kind of related it to plum pudding, which is that English dessert that looks like a cookie, basically, like a chocolate chip cookie. So that's why his model looks like this circle with polka dots. The polka dots kind of represent all of the positive particles kind of thrown out around the atom evenly. So he did find out that there were positive parts to the atom, but his orientation of them, the fact that he just thought they were scattered everywhere in the atom, we know that's not true, but he did, you know, discover the proton. Next, we have Rutherford, who he did experiments and found that the positive particles are in the center of the atom, in the nucleus, And he found that atoms are mostly empty space. And so he essentially found that protons are in the middle, in the nucleus, and then there are, is mostly empty space. Remember, Rutherford did the gold foil experiment, and that's where he shot gamma rays at a gold foil, and the gamma rays, which are just nuclei of hydrogen, and remember, nuclei are positive. So he just shot positive nuclei into the gold foil, and it either went through, which most of it went through, and that's how he concluded that atoms were mostly empty space. Some of them kind of went past the nucleus and then got deflected in a different direction because they got too close to the positive nucleus, and positive don't like to mix, so they're like, positive, bye. So it got deflected and turned into a different direction. So he knew that there was, in all that empty space, a positive part, which the atoms were getting close to. And then very occasionally, the alpha particles bounced back because it hit the very small nucleus and bounced back. But that didn't happen very often, so he knew that the nucleus was small. So he found that there are positive particles in the center, which is the nucleus. Atoms are mostly empty space. And then the nucleus is in the center, and it's very small. That's what Rutherford found out with his gold foil experiment. And then we have Bohr, which, fun fact, which I might put this as an extra credit question because, I don't know, I'm obnoxious. I might put this as an extra credit question on the test. Niels Bohr, which is this guy right here. This guy, that's Niels Bohr. He shares a birthday with me. He was born on October 7th in 1840 or something. No, whatever. But he was born on October 7th, and that is my birthday too. So him and I are both Libras, and we share a birthday. So I always call Bohr my birthday buddy Bohr. So I might ask you as an extra credit question, which scientist does Miss Murphy share a birthday with? And the answer would be Niels Bohr. I don't know. That's just something I found out that was funny. But what Bohr did is he took Rutherford's model, and he's like, okay, so we have positive particles in the middle, and then we have all this empty space. And so what he was thinking to himself is, okay, we have to have electrons in these empty spaces, and this is probably how they're arranged. So he came up with what we call the Bohr model, which was supposed to be part of this unit, but I cut it short so that the seniors could take this test without having to cram something new in. But the Bohr model basically just tells you that there's, you have your nucleus in the center, and then your electrons are organized into levels. So you have some electrons in this level, and then some electrons in this level. So he basically said that electrons aren't just, floating randomly outside the nucleus. They are, organized into levels, and those levels represent energy. So, Bohr was basically just famous for deciding that electrons were probably in energy levels, which we still think to be true today. And then finally, I'm going to move my face a little bit over here. I'm just going to move it over here. Okay. And so what Rutherford did was he just discovered neutrons, but so basically he expanded upon all the other models, so like Bohr's, and he said, okay, so Bohr, where the electrons are and how they're arranged. Okay, Rutherford, that protons are in the nucleus, but no one has said anything else about what's in the nucleus. And so he said that the nucleus had both protons, like Rutherford said, but then he also put in nucleons. Yes, that's a word. It's not. Neutrons. So he was like, okay, neutrons are also in the nucleus as well. So in the nucleus, we have protons and neutrons, and then, okay, Bohr, that's fine. You can keep your electrons. So I should have mentioned this 5 minutes ago, but I'm so sorry. But if you don't want to take notes on this slide, you don't have to because you have the foldable. So the whole reason I asked you guys to do the foldable was so that you guys could have like a study thing for the scientists. And so if you don't want to take notes on this, you don't have to. But if you did, that's okay because it's just extra practice, is extra memorization because you're writing it. So if you want to, you can, or if you already started, I'm sorry. But if you didn't and you don't want to, like, just make sure you study your foldable in whatever form you did it, online, on paper, or actually cut and paste. Okay, so now we can move on. So next, ruined. So next we have the periodic table, which technically, if we were going further, that would be the next unit, but obviously we're not going to get there. But briefly, how to read the periodic table, and I know you guys know this from a prior chapter, but basically, I wanted to make sure you guys knew what the numbers were, because as I was going through some of your assignments and stuff, some of you guys got your atomic number and your atomic mass mixed up. And I just want to clarify that here. So go ahead and draw this box and then make sure you label it. I know you already did this in the subatomic particles practice, but it doesn't hurt to do it again. So we have our box that you would see on the periodic table. The first number, obviously, is the, where am I? Is the atomic number. Then this letter right here is the element symbol, so we don't have to write out the whole name. Below the element symbol, we have the element's name, and then finally, below the element's name, we have the atomic weight. I want to mention here that, and I'm going to mention this probably 10 more times, that the atomic weight, so this is different than mass number. So I'm going to say like, not the same as. And the reason this is because you should have learned this doing your isotope review. When you clicked on that one link on isotope review below that table, it should have taken you to that tutorial where it calculated the atomic weight for carbon, and you were kind of seeing how like the abundance of carbon and the abundance of each isotope kind of were calculated together to get the atomic weight. So the atomic weight they consider to be an average of the isotopes and how abundant each isotope is. Okay, so I wanted to point that out here. So next we're going to break down all the subatomic particles. I'm going to write them with you. So there's no spoilers, I can just click to. So subatomic particles, oh, I'm so sorry, I need to mention this. So the number right here are your I can statements. So your I can statement was right here for this one. And then it's right here for this one, and then it's up here. So it's just going to be next to the title of the slide, just so you know. Okay, so I'm going to have the particle, I'm going to have the symbol of the particle, I'm going to have the charge, relative mass, and then additional info. And these are of the subatomic particles. So we know the 3 subatomic particles are, where's my thing? Oh, there it is. So first we have protons. Then we have neutrons. Then we have electrons. Okay, and the symbols are the first letter of each one of these words with what their charge is. So for protons, it's P+. For neutrons, it's N, 0. That's a 0. That's why I put the dash through it. And remember, neutrons don't have a charge. They're neutral. And then we have electrons, which are E-. And then the symbol already kind of gives it away. But our charges here, so for protons, remember protons are positive, so those would be +1. Remember, neutrons are neutral, so they don't have a charge at all. So those are just 0, zip, zippo. And then finally, we have electrons, which are negative, and those are -1. Okay? For relative mass, this is when I want you to think about when you did all those tables where you're calculating the mass number. And remember, mass number is protons plus neutrons. Remember, why don't we include electrons? Because electrons weigh basically nothing compared to electrons and neutrons. So I'm just going to put 0. I know in the formal notes that we did for these, it was like 1 out of like 5,000. But like for our purposes, it's 0. It's so small. It's such a small number that we're just going to put 0. So that's why electrons don't contribute to the weight, is because they're so small and weigh like basically nothing. Neutrons, remember, are 1. And protons, remember, are 1 as well. And then I put a part on the graph that says additional info. And the reason I did that is because I wanted to note some things, which I am going to say again later, but like just to have them all out in this little chart, I thought would be helpful. So I wanted to mention, remember, protons. So protons equal the atomic number, which is equal to the atom's identity. Oh, barely got it in there. So protons are equal to the atomic number, and the atomic number determines what element we're talking about. And then I'm going to put down here in nucleus, just so we know where it is. Neutrons, not a whole lot to say about them, except for they're in the nucleus. Electrons. So I'm going to say this. I never actually said this before, so this will not be on your test, but it's just kind of a fun fact that you probably should know. So electrons, so change in electron number results in a charge. So I'm going to explain that what I just wrote really quick. So remember I told you guys that if the protons, the positive protons, equal the number of negative electrons, then you have a neutral atom. What happens if they aren't equal? That means you either have more electrons, which would make a negative atom, or you have less electrons, and that would make a positive atom. Like I said, not going to be on your test, but you should probably know that still. So like I said, the change in the number of electrons, because remember, for the atom of a certain type, it will never change the amount of protons. Protons do not change. Electrons can change, which will change the charge. Neutrons will change, which makes isotopes, but protons will never change for that same element. Okay? But that's just what I mean for change in E results in a charge. Because if, an electron goes out, that means you have less electrons, and so your atom's positive. If another electron comes in, that means you have more electrons and your electron's negative. Just thought I'd mention that. And then electrons are located in what we call in the electron cloud. Okay? All right, so now we can move on now that we know all our subatomic particles. So now we're going to draw an electron. I know we did this before, but I want you to draw it again because, like I said, it can't hurt and it can just help you remember it. Okay? And FYI, I can always ask you on the test to draw me one of these using these pieces. Okay? So I could do that in the written part. So first we're going to do the nucleus. Come on. There we go. So first the nucleus is in the middle of the atom, right? And what's in the nucleus? Protons! Next, what's in the nucleus? Neutrons! Yay. I went a little nuts with my animations. Sorry, I'm obnoxious. And then where are the electrons? These little ones. So the electrons are going to be the smallest particle. Remember, they weigh basically nothing. And those are in the electron cloud, which is represented by the circle. So we have our electrons on the outer circle. Okay, so go ahead and take a minute to pause this video, draw a quick sketch of this again, because like I said, it can't hurt. And like I said, I could always have you do this on the written portion. Hint, hint. So something else I could have you do on the test is say, oh, what element is this? How would you know? Well, you can always count the number of protons, because we know the number of protons is equal to the atomic number, and the atomic number tells us what atom it is. So for example, this one, we have 1, 2, 3 protons. And if we looked at the periodic table, I think lithium has 3 protons because its atomic number is 3. So we would say, oh, this is lithium. So that's something I could ask you on the test. I could give you a model and say, count the number of protons. Or I probably wouldn't say that. I would just say, what element is this and how do you know? And you would say, oh, this is lithium because I can count the number of protons and I know that's equal to the atomic number. Okay, let's move on. So next, I'm going to kind of skip ahead to what we just did and talk about isotopes a little bit. So isotopes, remember, it's the same element, so it's atoms of the same element. It's just these atoms have different masses. They have the same number of protons, okay? Remember, atoms of the same element always have the same number of protons, okay? So we have the same element, so same number of protons, but different mass numbers. Why? Because we have a different number of neutrons. Remember, mass number is equal to neutrons plus protons. And since protons doesn't change, if a mass number is changing, it must be the neutrons, right? So I'm just going to write here really quick. Mass number is equal to protons plus neutrons. And I'm going to make a little note in a different color that says, for atoms of same element, protons don't change. Don't change. Okay, so if we have the same element and the mass number is different, we know the protons are not changing because we just wrote this. So it must be the neutrons that is the number of neutrons that is changing. Okay? And then I also want to put on this slide that atomic mass is a decimal, and you should have learned this in the isotope review that you just did. So the atomic mass is a decimal because its average is because it's an average of the different isotopes and the masses of each isotope. So for example, if you have like carbon 12, carbon 13, carbon 14. I think that's the mass of, or the atomic mass of carbon. And the reason why it's 12.01 and it's not just straight 12 and it's not just 13 and it's not just 14 is because the atomic mass, different from the mass number, is an average, okay? So it takes into account the abundance of that isotope. So say so carbon 12 is the most abundant, so say it's like 95% abundant, you'd multiply that by 12. And then I don't know, carbon 13 is like 3% abundant, and that's 13. And then carbon 14 is 2% abundant. and that's 14. So what you do this multiplication and everything, you'd add the products of all these together, and then you'd probably get something close to 12.011. So when people make atomic masses, they multiply the abundance of that isotope times the mass of that isotope, and then they add all of the isotopes together, and then they get their atomic mass. And so it's an average. And so that's why it's a decimal, which I might ask you. So now we're going to go back to a little review about how to do all the subatomic particle math. And so I wanted to remind you that the atomic number is the same as the number of protons, and the number of protons is the identity of that atom. Okay? So if I ask you, which I might, what subatomic particle is the identity of the element, you would say protons. Okay? The atomic mass, which I just went over, it's the average of all the isotope masses with the abundances. So I just went over that in the last slide. The mass number, which is different because it's not an average. The mass number is for an individual. So I'm going to write this. For an individual isotope. So that's why isotopes have a constant mass number and it's not a decimal. It's a whole number because it's just for that one isotope. The atomic mass is a mixture of all those isotopes averaged out. So that's why the atomic mass is a decimal. I'm actually going to write this. Whole number. And this is decimal. So you know the difference. And so the mass number is, remember, protons plus neutrons. I just wrote this on this slide. So the number of protons, number of neutrons. And then a neutral atom, I wanted to remind you guys, is just, so in a neutral atom, the number of protons is equal to the number of electrons. And this is just FYI. This is just for your information. This won't be on test. Maybe I'll make it a bonus problem. I don't know. Because I never exclusively said this in any lecture video that I had you guys watch, or you didn't do it in any practice. But I want you guys to know this, so maybe I will put it on as an extra credit question. But I want you guys to know if there are more protons than there are electrons, it's a positive ion. If there are more electrons than protons, then it's a negative ion. So there's more protons, positive. If there's more electrons, negative, which makes sense because you have more particle. Oh my gosh, no. If you have more positive protons, that means you would be positive. And if you have if you have more negative electrons, then your entire atom will be negative. Okay? So that's not something I'm going to hit you with on the test. I just wanted to make that known. And so whenever, I say in a video, neutral atoms are protons equals electrons, I just wanted to, touch on that in case I had any of you guys were interested in to know oh, what if we don't have a neutral atom? But in our practice problems, we always will for this test. And then I just wanted you guys to know that positive is more protons and then negative is more electrons. Okay, just for fun. So yay, it's another one of these tables that you're so used to doing and seeing. So I'm sure you're probably magic at this by now. Just so you guys know, when you guys did that subatomic particle practice, which I just graded, today is, Cinco de Mayo. So I graded that subatomic particle practice yesterday, and I only looked at the first page, which is the one that asked you to identify the number of protons, neutrons. It had the boxes, and you had to fill in the names in the boxes, and then below it say the number of protons, electrons, and everything. The page after that, called a world famous table, I just looked at it for completion. I didn't look to see if you actually did, or I looked to see if you did it. I didn't look to make sure you're right. So all my feedback for those worksheets is in the first page. So if you struggled with the table or anything, I didn't look into depth. But for this, I'm gonna do the table here now so that you guys do see me do it one more time, in case you guys did struggle with it. But I did not grade a world famous table and a now you know page. So I just looked at those for completion. But I did look at that first page in that assignment to make sure you're doing it right. I didn't take any points off if you're wrong. I just, gave you feedback and said like, oh, you got this wrong. It should be this. Okay, so let me get my periodic table out. Okay, so let me go find a periodic table. So now I have my periodic table open, which will help me complete this table. And I'll link this periodic table on the agenda the morning of your test next week so that you guys do have access to a good periodic table because I actually really like this periodic table. So first thing we have to do is nitrogen, okay? So we're going to look for nitrogen on the periodic table. And we need the symbol, atomic number, atomic mass. We need pretty much everything for it. So let's look at nitrogen for all this information. Okay, so let me see if I can find nitrogen. It's right here. Okay, so I'm going to look at it. I see its symbol is N. Its atomic number is 7. Okay, so let's fill those out really quick. So atomic number is 7 up here, and the symbol is N. So the symbol is N. And since we know the mass number, we're given the mass number, I'm going to put a dash, 15. The atomic number, I said, was 7. And what do we know that the atomic number is equal to? Protons, yay. So I'm going to put 7 here. We're assuming all of these atoms that we're doing in this table are going to be neutral, which means the number of protons is equal to the number of electrons, so we can already fill out the number of electrons. So now all we have to do is figure out the number of neutrons and the atomic mass. The atomic mass is going to be on the periodic table, so let's go get that really quick. So it looks like the atomic mass is 14.07. That's what it says right there. So 14.007. And I want to point out, I put atomic mass and mass number right next to each other on purpose. Remember, atomic mass is a decimal because it's an average. Mass number is going to be a whole number because this is just the mass of this isotope, okay? And finally, the number of neutrons is just the mass number minus the number of protons because remember, protons plus neutrons equals mass number. So I'm going to do 15 minus 7, which I know is 8. Okay, so that's our first row, and that's how to do it. In case you guys struggled, I know a lot of you, are perfectly fine with this, but I just want to do one last practice because since I've been doing some of these tables, you might think I put it on the test. I might put it on the test. So make sure you know how to do these tables, okay? So the next one we have we're given K39 and the number of electrons is 19. So right off the bat, what do we know about number of electrons in a neutral atom? It's equal to the number of protons. So we can easily go back and backtrack and say, okay, this is a neutral atom, so the number of electrons is equal to the number of protons. So they're both 19. What do we know about the number of protons? It's equal to the atomic number, right? So we're going to go ahead and say this atomic number is 19. One other thing we can do before we have to look at the periodic table, well, we can do 2 more things actually, is see how this is K39. Remember in that formative assessment quiz thing I had you guys do? I asked you guys what this number meant. Now you guys know. It means it's the mass number of this isotope. So if you see a letter and then a number right after it with a dash in chemistry, that's the mass number. So we know the mass number in this case is 39. One more thing we can do before we go to the periodic table to look for our atomic mass and our element name is we can get the number of neutrons. Remember, I'm just going to subtract the mass number minus the number of protons. So 39 minus 19 is 20. Now we have to go to the periodic table. So let's open up our periodic table to get our element name and our atomic mass. So let's see if we can find K. Okay, found it. So K is right here. Okay, so it looks like the element name is potassium. So K is potassium. And so another thing we need to get is our atomic mass, which is 39.098. 39.098. Okay, so we know our atomic mass is 39.098, and this element is potassium. Okay, 2 more to go real quick, so we can do this a little faster since we're so, good at this and so used to doing this table over and over again. So we are given atomic number and mass number. First thing I'm going to do before I even go to the periodic table is I know the atomic number is equal to the number of protons, so say 80. I also know that this is a neutral atom, so the number of protons is equal to the number of electrons, so this should also be 80. And I can also do the number of neutrons because it's the mass number minus the number of protons. So let me get a calculator super quick. So what is it? 201 minus 80. And we get 121. So 121. And now we have to go to the periodic table for our atomic mass, our symbol, and what element this is. Okay, so let's go to the periodic table really quick. And all we know is our atomic number is 80. Okay, so we have to look for 80. So let's find 80. So we know the periodic table goes up in atomic numbers from left to right. It goes up. So I don't see it in this row. 78, 79, 80. So it looks like our atomic symbol is Hg. We have mercury here. So this is Hg is the symbol. Mercury is the element name. And then our atomic mass is 200.592. So first, before I forget, I'm going to do 200.592. That's our atomic mass. The symbol was Hg. And this was mercury. I feel like I just spelled that wrong, but whatever. If you guys spell it wrong, and I can tell what you're saying, I probably won't give you points off. If you spell it wrong and I have no idea what word you're trying to spell, then I'll give you points off because I'll be like, I don't know what this is. But if you spell it wrong, like I probably just spelled mercury and potassium wrong, then, I probably won't even notice, so I won't give you points off for misspelling it. Okay, last one. So we have number of protons, number of neutrons, number of electrons. So first things first, the number of protons is equal to the atomic number. So we know the atomic number by association. So we know the number of protons is 17. So the atomic number must be 17 as well. We can do the mass number too. And because we have the number of neutrons and the number of protons. So we're just going to add those two together. So 17 plus 18 is 35. Yeah, it's 35. Okay. And so now we need the atomic mass, the symbol, and what element this is. So let's go to the periodic table one last time. So our atomic number is 17. So let's look for 17. Oh, atomic number 17 is right here. And it looks like it's chlorine. So our element name is chlorine. Our atomic symbol is Cl. And it has an atomic mass of 35.453. So 35.453. So 35. 5.453. And so I just said that it was Cl and it's chlorine. Okay, so that is how to do one of these tables if you guys are struggling. I know most of you guys, this is pretty easy for you, which I'm very glad because, and I'm glad it's easy for you. So you should expect something like this on the test, like maybe just like this, where you'll be given a few things and you'll have to look at the periodic table for some information. You can do some adding and subtracting for mass number and neutrons and protons and stuff like that. And then just remember the atomic number is equal to the number of protons. Okay, so that pretty much concludes everything that we've gone over this unit. So as a review, you need to know about subatomic particles. You need to know a little bit about how the atomic theory happened, who discovered what, and remember, this is open notes, so you don't have to memorize everything. Okay, so you can just use your foldable, or if you did write notes from that slide, you can use that. So this test is open note, so please use these notes that you're taking to help you, okay? That's why I let it be an open note. Even if we were in person school, I'd probably still make this open note, honestly. I just think it's fair. Because in the real world, you have, the internet, which is going to help you. So I doubt in the real world, unless you go to college, you're not going to have to memorize things. You'll just get to look it up. So I figured, you can at least use your notes here. Please do not use your friends because, if I think you're copying like short answers or something, I'm going to mark you as 0. And I'll say like, I think you're copying because this answer was exactly the same as like I'm not going to tell you whose it was the same as, but I'm going to say this is exactly the same as another student's answer. So hopefully this helped you it helped kind of reiterate all this information that we've learned this unit. So if you need me to, I can answer any questions you have about the test, anything you have about these topics. I hope me going over examples and stuff with you guys helped. Make sure you submit a picture of me to Google Classroom into the assignment with a picture of your handwritten notes from this video so I can give you points for it, okay? I will give more details to the test, probably in writing, later on this week, so maybe tomorrow or, Monday morning or something like that. So just look out for that. And then I will let you know if I decide the test should be on Tuesday or Wednesday. I haven't decided yet. But make sure when you do take the test, take both parts, the written and the multiple choice, because you don't want unnecessary points taken off just because you didn't take portion of it. Okay? So good luck studying. Ask me any questions you have because I want to know them. I don't want you to struggle. So good luck studying and let me know.